Thank you very much for attending this talk. Today I will solve some problems in moving average. I will start from a very simple problem and then gradually I will go into one or two problems which you may consider them not easy. We're talking about moving average, which is a forecasting method which uses a number of most recent data. Usually when we have a trend in our actual data, we need to polish a little bit moving average. Sometimes we need to lift it up a little bit. Today I mostly talk about the general concepts. Here I have 8 pieces of data. I have referred to them as periods 1 to 8. Now suppose we want to compute moving average for 1 period, 2 period, 3 period, and so on and so forth. In general, as I have already explained, a person may be very conservative, and when we ask what is the forecast for period 9, he may tell us, I'm going to add all these numbers. This will be 8 period moving average for period 8, and then I will consider it as my forecast for period 9. That is one idea. The other person may say, no, I only take 1 period and assume it as moving average for that period and assume it as forecast for the next period. In that case, this will be forecast for period 2, forecast for period 3, forecast for period 4, and forecast for period 9. Someone may come and say, I compute 2 periods as forecast for next period. One may take 4 period moving average. This is 4 period moving average for period 8, and then I may consider that one as my forecast for period 9. Here are the formulas that I have put for all periods, 1 period, 7 period moving average. Don't forget, moving average is computed for a period. For example, 5 period moving average in period 7 is average of the last 5 pieces of data, which is 7, 6, 5, 4, and 3. That is 5 period moving average in period 7. And then we take it to period 8 as our forecast for period 8 based on 5 period moving average in period 7. And continue that. And we have already gone through these issues. 3 period moving average for period 5 is summation of these 3 numbers divided by 3. Average of those 3 numbers. So this one has 2 more than 65, this one has 7 more than 65. They both together have 9 more than 65. 9 divided by 3 is 3. So the moving average is 68. Summation of these 3 divided by 3 would be 68, and that would be our forecast for the next period. Okay. And that is the formula. Now compute 3 period moving average for period 6. That is a concept I need to clarify it. We compute moving average for period 5. This is 3 period moving average in period 5, but we take it as our forecast for period 6. That is 3 period moving average in period 5, which is our forecast for period 6. If you look, these two formulas are exactly the same. These are some terminologies and notations that I have. If in the future slides there is a notation that you do not follow, you may come to this page and exactly see what that notation means. But when I'm explaining those material, I explain the notation too. This page is only here. If you have any difficulties, you come back and refer to this notation and their meaning. So now we have a problem. This is 10 period data that we have. If I'm going to use naive technique and next period moving average, I take the actual of one period and put it as my forecast for the next period, and formulas are also here. If we are talking about 3 period moving average, I should take 3 periods, average them. That would be 3 period moving average in period 3, but I consider it as my forecast in period 4. And here, if we are talking about 5 period moving average, 5 period moving average will not be available until period 5. And then it is in period 5 when I consider it as the average of these first 5 numbers, and then I will take it and put it as my forecast for period 6. And then 8 period moving average will not be available until period 8. In period 8, I will compute moving average for period 8, and then I will put it as my forecast for period 9. So I'll take the average of first 8 periods, that is 8 period moving average in period 8, and I will consider it as my forecast for period 9. Now we have a problem here, part A, compute 2 period moving average in month 5 or in period 5 and 9 period moving average in month 10 or period 10. For 2 period moving average in month 5, I will go to month 5. This is month 5. And I take the last 2 numbers and average them. Obviously, I just add them and divide them by 2. That would be my 2 period moving average in month 5, and I put it in month 5 because he has not said do forecasting. The problem has only asked compute 2 period moving average in month 5 and 9 period moving average in month 10. So I will go to month 10. I need to compute 9 period. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 period. I take these 9 numbers and average them. And these are the answers. Formulas are there, computations are there, everything is there. And this is here, for example, I have used notation MA 5 and 2 for month 5 and 2 period moving average. The second problem asks compute 2 period moving average forecast in month 6 and 9 period moving average forecast in month 11. So I already have 2 period moving average in month 5. The problem asks compute 2 period moving average forecast in month 6. Moving average forecast. That means in month 6, I do not have the data yet. I have data up to month 5. 2 periods. So I take the actual data of month 5, actual data of month 4, average them. That would be 2 period moving average in month 5, which is my forecast for month 6. And I already have 9 period moving average in month 10. That would be my forecast for month 11. Here are the information and here are the formulas. Compute 4 period moving average for all periods. 4 period moving average will not be available until month 4. That is the first time that I will have 4-period moving average. I average them and I put it here. But it asks for every month. So I'll take the next 4 months and I put it over there. And the next 4 months and I put it over there. And the last 4 months and I put it over there. And we have a simple formula. This row, the row before it, the row 2 before it, the row 3 before it, and then copy it down. When I go to the next one, things will remain the same. Take this one and 1 before it, 1 2 before it, and 1 3 before it, and then look at this anymore. And that will put it over there. This is the formula for moving average for all periods. Results and the corresponding formulas are over here. Compute 4-period moving average for all months, including the next month. The next month, we have up to month 12. The next month is month 13. This will be my forecast for this month, for this month, for this month, for this month, for this month. And this last one is my forecast for the next month. And here are all the formulas. So read this question and tell me which one of these choices is the correct answer. Whether larger number of periods leads to a smooth curve or a smaller number of periods. Whether larger number of periods provide more responsive curve or smaller number of periods. Don't worry about alpha. This question I should give it to you after I teach exponential smoothing, but for the time being you may ignore those two. Later on we will discuss them, whether large alpha makes a curve smooth or a small alpha. But right now, between the other choices, which one is your choice? When number of periods go up, more up and downs compensate for each other and the curve becomes more smooth. Here we have Apple's data during this curve, which is associated with 100-day moving average, is very smooth. This curve is actual. This curve is 5-period moving average. This curve is 10-period moving average. 5-period moving average, and period here is day, 5-day moving average is quite responsive, but 100-period moving average tries to identify general long-term slopes. When the number of periods goes up, curves become more smooth. When the number of periods goes down, it shows more fluctuation. That is what we refer to as more responsive, response to most current changes. Compute the age of data in 3-period moving average. Not in 3-period moving average, in 3-period moving average forecast. So that is 3-period moving average in 1 period, which has been used as a forecast for the next period. 3 pieces of data. One of them belongs to immediate past period, which is 1 period old. One of them is 2 periods old, and one of them is 3 periods old. Divided by 3, and that is 6 divided by 3, which is equal to 2. However, whenever we have a linear fashion, something is increased by a linear rate or is decreased by linear rate, we don't need to go through all intermediate points. We can take the first point and the last point and average them. For example, in this case, the first period is 1 period old, the last period is 3 periods old, and we divide them by 2, and we will get the same 2 as we found it here. We do it in many other situations. For example, we do it for flow time, we do it for average inventory. Whenever you have some numbers, some values, which either increase by a specific rate or decrease by a specific rate. So each period, when we go from one point to the other point, it is say X unit more or X units less. Therefore, we don't need to take all of those intermediate points and average them. We just take the first one, the last one, assume there is a linear relationship between them, and divide it by 2. And this is just what I have explained. Even sometimes when relationships are not linear, for example, if the relationship, instead of being like this exactly on the same line, if it is something like this, again we can assume that it is a linear relationship. We can take the first one and the last one and divide it by 2. Compute the age of data in 7 period moving average. Quite simple. 1 plus 7 divided by 2, and that is 4. And 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 divided by 7 is also equal to 4. Indeed, you may take this 2 and divided by 2, it is 4. You may take this 2 and divided by 2, it is 4. You may take this 2 and divide it by 2, which is 4, and this one is also 4. Therefore, the average is 4. Now let's see if you can solve this problem. You may pause my talk and solve it. Solve this problem and the next problem. If you can solve these 2 problems, it means that you have a good grasp of moving average. 5 period moving average in month 6 is A6 plus A5, A4, A3, A2 divided by 5. That is the meaning of average. Add them together, divided by 5. 6 period moving average in month 7 has all elements of 5 period in month 6 plus another element which is A7. Here, this is the difference between these 2. These parts are common, but here we have this one added. One other difference is here I have 6 and here I do have 5. But I know that this is equal to 150. So if that is equal to 150, I can multiply 5 by 150 and I can get 750. Right? Now I have this part which is 750 and I have this part which is 180. So there is 180 plus 750 divided by 6, and that would be the results. This is equal to 150. Therefore, this part is 750. A7 is 180. We write the equation, and therefore we get 155. But there are many ways to solve this problem. For example, I could have said this is equal to 150. Therefore, this is 150, this is 150, this is 150, this is 150, and all of them are 150. I can assume. No one can tell me that cannot be a solution. All of them are 150. And if this one, A7, was also 150, therefore the answer was 150. Average of those 5 numbers is 150. I can assume each of them is 150. And if A7 was also 150, therefore all of these 6 numbers are 150. When I divide them by 6, it will be 150. However, this A7, it is not 150. It is 180. 180 minus 150 is equal to 30. So that one has 30 extra units, and that should be distributed between 6 components. 30 divided by 6 is 5. Therefore, 150 plus 5, 155. This is another example. You may put me on pause and solve it quickly. 4-period moving average in month 7 was 110. I assume all of them are 110. Demand in month 8 is 160. 5-period moving average in month 8. That is A8 plus A7 plus A6 plus A5 plus A4 average divided by 5. I assume each of them is 110. This one is 160. If it was also 110, the average was 110. Right? But it is not 110, it is 160, which is 50 units more than 110. And there are 5 components over there. 50 divided by 5 is 10, plus 110 is equal to 120. You may put me on pause and ever think about this problem, see if you know the solution, then we can go through it. So we have 5-period moving average in a period, and we want to compute 5-period moving average in the next period. The most recent piece of data, and we have the oldest piece of data, and we want to know how to go from one period to the next one. This is the notation as I have used for 5-period moving average in period 20. That is A20, A19, 18, 17, and 16 divided by 5. And this is 5-period moving average for period 21. This is 800. This one we don't know. So indeed this is blue plus red divided by 5. Blue and red, we know it is 850 in month 16, plus blue is divided by 5 is equal to 800, and therefore blue is equal to 3150. And now I can take that blue and put it here. Blue plus 821 is equal to what? Blue is this one, A21 is 900. blue plus 900 divided by 5, and that we have it, and therefore we compute it is 810. So indeed what we did, we took the moving average of the previous period, subtracted the oldest piece of data divided by 5, and added the new piece of data divided by 5. Let me explain it in a different way. I have 5 period moving average in period 20, and this is 5 period moving average in period 21. As I explained in period 21, we have all pieces except this piece. But we also have this piece which has been divided by 5. Therefore, if I have 800, all I need to do is to subtract A16 divided by 5 and add A21 divided by 5. 5 period moving average in period 21 is 800 plus A21, which was 900, minus A16, which is 850, divided by the number of periods, which is 5, equal to 800 plus 10, which is equal to 810. Right? We could have also used solver to do this, and I will explain. I take this problem to Excel. So this is mount 20 and this is mount 21. Suppose 5 period moving average in mount 20 is 800. So this is 20, this is 16. Right click, copy it down, fill series. In mount 16, it is 850. So this is moving average. And in mount 21, my data is, let me change these places and put this one over there. I have some reasons for that. Equal to average. Average of what? Average of 1, 2, 3, 4, 5 numbers. And because these are blanks, they are not zero, it assumes it is 850. And here I copied down, that is average of these 5 numbers. If I enter 0 over there, copy it down, it is obvious that computations are incorrect. Now I go to data solver. Solver, please change these numbers, those numbers that I don't know, such that the value of this average, this value is equal to 800. Of course, with a simple equation, you can also do the same thing. But I am saying, suppose you don't know even how to solve one equation, one unknown. Solve. I don't know, this is a problem that I frequently see in Excel. And if you know what is the issue, let me know. It automatically goes on manual computations and doesn't come out. I mean, even if you go and fix it, if you go here, formulas to calculation object, it has gone on manual. If you go and make it automatic, data, solver, solve, still give you the same. But I have not been able to find the source. The only solution I have found for it, and this is what you should do in exams or that, I will go here and I will come here, copy, and then file, new, and then I open this one, and I simply paste it over there. Everything is pasted. Data solver, please look into this number by changing these numbers, make it equal to 800. So now we have these numbers, which can be one of the alternatives. And therefore, when we average the past 5 periods, that is what we get. As simple as that one.